So after last night's test flight and then toilet bowling issue, I went ahead and pulled the logs and went over them, and I found that indeed the magnetic compass had an issue. I had the internal compass as the primary, and you're really supposed to use the external compass, primarily because the internal compass is surrounded by electronics and you have all the motor ESCs running into the controller. So it's very likely the compasses there will get interference, and it did. I went ahead, calibrated the compass, moved the external to the primary, and then I've armed the motors, gave it a little bit of throttle, shut it down, went ahead and pulled the logs, pulled it up. It's showing good compass now. So if this wind holds off, I may be able to try to fly this thing. I think in loiter mode it's going to hold, so we're going to give this a shot. All right, looks like we're good to go. Wind's holding off for a minute. I'm going to go ahead and try to fly it. As soon as I say that, wind picks up. That's what it's supposed to do. You could see the yaw and the pitch change, and that was it compensating for the wind. What happened, exactly what it should happen. As soon as it went low, the ground effect began to affect it. It automatically compensate. It was super easy to lift off, super easy to hold, super easy to land. I know it's kind of a cliche, but whatever. So I'm happy with that. I need to auto tune this thing, and I'm kind of reluctant to do it today because I got to do it in manual flight mode. And with this wind picking up, the gusts, there's not much wind, but the gusts are probably like 8-9 miles an hour. It's enough to move a big copter like this. So, but that was beautiful. Try one more flight while the wind's still just picked up again. We're gonna hold off. Yaw rate's good. Pitch and roll, I'm still a little reluctant to try it yet. I know it's doing good, but I don't want to get cocky and end up losing something. So I'm going to keep the flights short as the wind, and keep tuning this thing. Once it gets an auto tune, this thing's going to rock. Good stuff. Coating on that thing is pretty significant. So I got it.
How in the world do you test it? Battery.
I guess, oh, no, I put the landing gear down.
I heard it say something.
Battery 2, voltage low, fail safe. Closer look at this Terra frame. This is a Terra X8. It's a very large octocopter. The wingspan from motor, well, from prop to prop is 54.5 inches, and motor center to center is like 46 inches. It's very big. Right now I'm running two DJI M100 Matrice 100 batteries. I've got redundant battery systems. The top there is a 3D printed top. I didn't design that, it was already on Thingiverse. Another gentleman designed it, so thanks to him for that. It's a very nice little system. That's the Hex Cube, Orange Cube ADS-B, and running a Radio Master TX16 transmitter and the Radio Master FR Sky receiver. Telemetry, I can't get the telemetry to work on the remote yet. That's the next project now that I got this thing flying halfway decent. Using a Holy Bro 913 megahertz telemetry transmitter and receiver on the computer to get telemetry data back. This is the Cadix FPV camera. It's not hooked up yet. Now the GPS and magnetic compass is a Pixhawk 4, and I'm running this on a Pixhawk 2.1. I modified the JST plug and then tapped in because the switch wouldn't work when I rewired it. Put the switch in line until I get the correct hex GPS. Eventually this thing will have dual GPS, and it'll be able to actually do blending between the two for more accurate, and it will be RTK GNSS enabled, so I will have RTK on this eventually with a ground station. Next things are going to be a downward facing LiDAR sensor and optical flow sensor, and eventually a 360-degree LiDAR module for object avoidance. But it's been a slow process. You can see I've got orange tape over here, and this is so I can tell where the yaw is as I get used to this thing. Used to quads, and it's a lot different with an octocopter because it's round, so it's really easy to lose the yaw in the midst of flying. So hopefully that'll help. Everything else, as you can see here, I've got ducts. The ESCs are inside the arms. These are oval aluminum arms, so I wired the ESCs inside the arms. It made it for a clean install. It gives a little bit of shielding with the aluminum around them and helps shield some of the interference to the flight control module. Because they're inside and they do get warm, they're 40 amp opto isolated ESCs for these brushless motors. I put and 3D printed, I designed a little air scoop there. So in the downdraft from the props, it pushes air into the arms and it basically circulates out the bottom, and that allows to draw some of that heat and give a little bit of airflow to the ESCs that are inside there. Currently I've got a lot of wiring tucked underneath. I ran wiring into these arms. Eventually all the arms will have LEDs. The LEDs will be color coordinated for standard nav lights. I'm going to have some downward facing landing lights, and then obviously a beacon on top. All of that's going to be controlled via the RC. So I think I'm going to put it up and fly it again, and we'll see how that goes. Hopefully it doesn't crash.